In section 8.3, we're looking at hypothesis testing again, except for this time, unlike the previous section, we will not be testing claims about a proportion or probability P. Now we will be testing a claim about a mean mu. So we are going to want to test a claim about an entire population mean, mu, by using information from a sample. Just like the last section, though, we will again do all of our problems involving hypothesis testing using both methods. Remember, those two methods were called p-values and rejection regions, and they both give us the same values. They're just done in slightly different ways. Just like before, for testing using p-values, we will start by coming up with the null hypothesis and alternative hypothesis by determining where the claim is going to fit based on what symbols are in the claim. Remember, if there's any type of equal to symbol, we will stick our claim as the null hypothesis. If there is a strict less than, greater than, or not equal to, we will put our claim as the alternative hypothesis. And then once we've figured out where the claim fits, the alternative or null hypothesis that is missing will be the complement of what we've already found. Then we can determine what type of test we're actually going to use, whether that be a right-tailed, two-tailed, or left-tailed. This will be determined always, though, by the symbol used in H1. The alternative hypothesis H1 either will have a less than, a greater than, or a not equal to. The less than means that we will be looking at a left-tailed, the greater than would mean a right-tailed, and a not equal to would mean a two-tailed. Then we can sketch a graph, and the p-value will just end up being the area in the tail or tails if it's a two-tailed test. Then what we can do is run the appropriate test in our calculator, which will find a z value or a t value, and it will also calculate our p value, the area in the tail or tails for us. So the question is, how do we know if we're going to use z's or t's? Well, how we know whether or not we're going to use z's or t's is going to be based on whether or not we have the population standard deviation sigma. Just like in chapter 7, how we knew the difference as to whether or not we were going to do confidence intervals using z's or t's was based on whether or not we had the population standard deviation sigma. It will be the same here. If we don't have the population standard deviation sigma, we're going to have to use t's. If we do have the population standard deviation sigma, then we can use z's. So just like before, there was a z interval and a t interval back in chapter 7. Now there's going to be a z test and a t test. Now if we go ahead and look at what the z test and the t test look like, their programs inside of our calculator have two options, either data or statistics. Well, that's going to be based on the problem as to whether or not they give us a bunch of data in a list. Then we'll use the data option. Notice, even if they give us data, if they do not give us sigma, we are stuck with a t-test. However, if they do give us a set of data and they do give us sigma, we can enter it, and then we can still do a z-test. Also, they don't have to give us a set of data. They could just give us a bunch of statistics in our problem, in which case we can enter those into either a z-test or a t-test. Again, notice that they do give us an option on z-test or t-test based on whether or not we have sigma or not. Notice the z-test, if you look at the list of information you're supposed to input, is you're supposed to input sigma. That's a good hint or a reminder that you can use. Also, look at the t-test for the information you're supposed to input. Notice they use S, which means the sample standard deviation, not the population. That's again a reminder as to what kind of test you need to do based on the information that's given. After we run either our z-test or our t-test, what will pop out is either a z or a t value. So we'll either have a z value or a t value, but either way, we will always get a p value. If we're doing the p-values approach, then we can just ask the same question we did in the previous section, which is p less than or equal to alpha? Remember, this question always stays the same, whether or not this is left-tailed, right-tailed, or two-tailed. So will the answers. If we say yes, the p-value is less than or equal to alpha, then we will reject H naught. If the answer is no, then we will fail to reject H naught. Remember, failing to reject is not the same as accepting. It means that your test is basically inconclusive when it comes to rejecting H naught. At the very end, after we've completed our test and we've determined whether or not we're rejecting or failing to reject H naught, then we can figure out what that means in context of the original claim.